How's it going, everybody? I wanted to come back and finish up a couple things, and nothing major. Um, just as a heads up to everybody, currently the 640 802, 640 816, and 640 822. Those are all CCNA certification numbers that if you were going to test to take or going to go sit to take a CCNA exam, well, the 640-822 is actually the CCENT exam number. The 640-816 and the 640-802 give you the true CCNA exam numbers. The 640-816 and the 640-822 give you the CCNA, which is the 640-802. 802 is a combination of the 816 and the 822 exam numbers. So basically, I know I just threw a bunch at you, but if you go to Cisco's website, you have until September 30th, 2013 to take these exams in order to earn the CCNA. And it's a lot of people that I work with, or not that I work with, a lot of people that I deal with in the Cisco world, we all completely agree with this change. There's a lot of changes to it, a lot of good changes, a lot of needed changes. I know a lot of people that have a CCNA and they can't even tell you how the root bridge election process works in Spanning Tree. And that's kind of like a core knowledge type of thing. If you don't know how that works, how are you going to know how to troubleshoot your switched environment? Currently the CCNA only has us working on a single area OSPF, which I'm going to pull up the this guy right here, and the CCNA. Sorry, I got thought my wife was calling me. Let me. I'm waiting for Adobe Reader to start responding again so that I can drag over the case study information. And it's taking its sweet old time. So what we're going to do is pull it up. I know it just bugged out on me. So you know what? I'm going to hang on, I'll pull it up. So as I was saying, I pulled the case study up, and one of the main things I wanted to point out to you guys was this. As soon as my computer catches up, I don't know. It's just sometimes Windows can irritate me quickly. I've just had it's been a busy day, and I've had a lot of other. You ever get those days where you have so much to get done and you don't have enough time to get it done, and then a bunch of people come to you and say, "Hey, can you do this?" And you have to go step by step by step, and then go over steps 1 through 10. 3-4 dozen times before you get it right, and it's somebody else's grade, and you're responsible for putting it together. And you're like, I have stuff that I have to do. I don't have time to do yours. Can somebody else step in and do this? Because it's not like this complicated thing where click and drag. It's pretty straightforward stuff. But that's what you deal with. As I was saying, I just had to vent a little bit. I apologize if you guys had to listen to my rant. But anyway, the one thing that the old CCNA exam covered was single area OSPF, meaning only one area would be used. Now, if you CCNA material and you're familiar with OSPF, you will know that all areas must directly connect to OSPF Area 0. That is a must-have. And I hear the one person that I can't actually hear you, but I know what you're thinking. Well, what happens if you have an area that's not directly connected? Well, you can have, and I'm not going to really, it's going to pretty much be like this. So, let's assume, just for a minute here, I'm going to draw a circle real quick. And I'm going to draw the circle like this. Now, this entire area, for the lack of a better argument, is all OSPF Area 0, okay? I'm not going to include this guy simply for the fact that I don't want to go that far. But this entire area is OSPF Area 0, okay? So with that being said, Okay, we're going to put it on those two interfaces because it's not actually running on this guy yet, because this guy is a 192 network. So with that being said, if you had another router, okay, let's say I'm not going to turn this 3725 on, I'm just going to drag it out. Give it a minute to do its thing. And yeah, I know it's boy, I think, oh, did it? Yeah, okay, cool. Let's assume for just a minute here, and this is more of a tangent thing. I just want to clarify some stuff for you so you guys aren't going to be like, what do I do? Multi-area OSPF. Now it goes, well, I can't say it goes beyond the scope of the CCNA exam because it's, quite honestly, it should be enrolled in the CCNA exam because it's really, really easy to do. Stupid simple if you ask me. But all you're going to do is this interface right here. So we're going to say serial 01. Okay, this interface right here and serial 02. They're both in OSPF area 0. Okay, if I was to take the fast Ethernet connection, if I had one, and connect it to here, okay, this guy is off. I'm not going to boot him out. This is more of a theory situation at the moment. But let's say, for instance, this guy right here, this is area 1. Okay, this is area 1. In order for these two areas to work, you have to have an area border router. Well, area border routers merge different areas. So if you have area 0 here and you have area 1 over here, R1 becomes an area border router. So that's what you need. This is the only place, well, this is an autonomous, actually this is an ASBR because it goes out beyond the area border router. Because area border routers are specific to just OSPF. So if OSPF is the only routing protocol being ran, then that's an area border router because it's the only routing protocol being used. If you're using a static route, if you're using a default route, you're using RIP, BGP, ISIS, MPLS. I can keep going. If you're using any other routing protocol other than OSPF, this guy right here is considered an autonomous system border router because it's going from one autonomous system to the other. Okay, so this guy right here connected up to my home internet connection. This guy is connected to it through the cloud. What does that mean? Well, autonomous system border routers and area border routers are the only two places in OSPF that you can summarize. So let's say, for instance, this router right here had 100 other routes behind it, okay? And these 100 other routes were being advertised by OSPF to all the other OSPF routers in area 0. Okay, let me clear. I'm going to go out here on a tangent for a minute. All these area 0 routes, or all these area 0 routers, these backbone routers, if you will, the internal routers, those are the only ones that are going to need to know about those routes. Okay, this guy over here, let's say he's got 1,000 routes. Okay, he's a major corporation. He's the edge router for this corporation. This is just more of a theory. I don't actually have 1,000 routes configured on it. That'd be a lot of typing. So this guy's got 1,000 routes associated to him. If you were to connect him to this router and make this area 1 over here, and this guy be an ABR, an area border router, this guy is a backbone router, an internal router, and this guy right here is an ASBR because he's doubling up. He's an area border router because he sits on the border of area 1 and area 0. So area 0, area 1, and he's also an ASBR because he sits on the border of an OSPF routing domain and a non-OSPF routing domain. So that right there makes him an ASBR/ABR. Well, can one be the same? Yes, they can, absolutely. So what you need to do at that point is you need to configure the routes to point out this way. So anything that he's going to advertise in here, let's say for instance he's got the 10.01 or 10.10 network slash, let's say 1,000 routes. That would be what /17. He's going to advertise a 10.1/17 summary route from here to this guy on area 1. So area 1's this interface right here. Actually, let me wrong button. Click off, click on, click off. Yes. So this guy right here is fast 1. Okay. Fast 1 is area 1. Fast serial 0/1 and 2 are area 0. So fast 1 is in area 1. Serial 0 and serial 01 and 02 are in area 0. This guy here will advertise a summary route into this guy. Well, this guy will say, okay, I have these 1,000 routes, and he will advertise a summary route into this guy. This guy will take that route, and then he will advertise just that single route. Is that everybody tracking on that? This guy will advertise a single summary route. Well, as long as it encompasses inside of a summary. If it goes beyond by a couple routes, those extras will be additional routes individually. It goes based on your subnetting, and I've explained it. There's a whole video on my YouTube channel that explains summarization. But the whole point of this is he'll advertise an entire summary route, with maybe a few additional stragglers, up to and including the next bit placement in the summary route. So the higher up you go, the more routes you get in, as long as you know how to look at the class C to class B. So if you have 1,000 routes, you're probably going to have like a /18 or /17 subnet mask, like what would that be, 16, that'd be a 255.128, or 192, something like that, something very large. So you'd have this guy advertising that size of a subnet to this guy. It's called a supernet or an aggregate route. So you're going to have all these routes advertised to this guy. This guy's going to advertise these routes into here. So what will end up happening is this guy says, okay, I need to get to one of these routes over here. So he'll ship it out up here, come over the frame circuit, hit this guy, and then it'll be more of like a default route is what it'll look like. It'll actually be an OSPF route. It'll be in IA because it's an intra-area route. It'll go from here to here and then shoot out this way. Now, the thing with OSPF is I've seen a lot of people, when they express how they want to set it up, they'll pull out an Ethernet switch, they'll do one of these things, and then they'll have a router here, and they'll have 4 routers over here. Okay, the idea, and they'll have router here, router here, router here, router here. So the point, well actually I should just do this. How about that? So they'll put this guy right here. Well, actually, I should do it this way. This would be the easiest way to make it work. Let's assume for a second that this guy right here is a switch, and then he's got over here on this is area 10, and this is area 20. Okay, so this router right here is area 0. So these guys are actually directly connected because this all switches is just a transparent bridge from here to here. All it does is change MAC addresses from one place to another. So when stuff needs to come to this router, even though I know this is a picture of a switch, all it does is it switches the MAC address. That's all it does. It's transparent. It just converts the frame. It just flips the frame. So this guy sends information to this guy who is an ABR, an area border router, because he's connected. He has routes to here. So that's basically the concept to it. Now I know it's kind of to me it's not a really good theory video because I'm not actually showing you how this stuff works and stuff like that, but I felt like I needed to throw that out there because quite honestly the way that this lab is set up with the requirements, and I'll slide this down here just a little bit when it comes to as soon as it catches up. Not quite far enough yet. When they start talking about OSPF, you're not going to get OSPF to work on a that's aggravating. Where did it go? These are the ACLs. Actually, that's my next video. Is this stuff that won't be happening tonight though? Let's see here. Trying to find it. Because as soon as I see it, I'll be able to point it out to you. That's switching in lands. I bet you it's up here towards the top. I don't know. I can tell my processor's spiked out because it's going slow. But anyway, yeah, this is VLAN's DHCP. We've already configured that. I've already got most of the videos shot for this stuff. Oh, here it is, right here. Configure OSPF Area 0 routing protocol to the HQ, Plymouth, Pool, and Bournemouth routers. Well, this is Exeter, which is your HQ. this is Plymouth, this is Poole, this is Bournemouth. Well, in order for you to be able to get routes to here, if you guys are going to be doing this in Packet Tracer, I don't know if it's going to work. I don't think it's going to. Because in order for you, this guy is acting as the hub. Even if you are running, and I may lose some people with this statement, even if you're running multi-point sub-interfaces for your NBMA network, which basically means on your serial interface you're creating sub-interfaces, serial 0/0 dot, whatever, Delcy number would be a smart thing to go with. And then over here you're doing the same thing. All sub-interfaces, and you're making them multi-point, so that you can route more than one Delcy so you can make it a full mesh. You'll be able to put more than one Delcy. If you make it a point-to-point, your configuration is also going to be different. So with that being said, the best way for you guys to look at this, you may be able to go underneath the sub-interface. Now, but you may have to put on the serial interface, or it might have to go under the sub-interface. But you may have to go in there and type in IP OSPF priority 0 under the interface configuration to prevent the spoke routers, because these guys are going to be spokes, from preventing them from being in the DR, the designated router, and the backup designated router election process. Because by default they get a priority of 1. So if all 3 routers have a priority of 1, does anybody know what breaks that? Well, if you did say that it goes based on the highest loopback IP address, you would be right. Or if there's no loopbacks, it'll go based on the highest configured interface IP address. So this guy right here, R3, is a .139 in my network. So this is .137, 138, 139. So this is 139. If you did not change anything with the DR election process and configuration, this guy would become your DR, this guy would be your BDR, this guy would be your druther. He wouldn't be a DR or anything else. He'd just be a regular router. So in order for that to work, you have to change the port priority cost on here. So change the port priority to 0 on both of these guys, and then it'll come up. Now on R1, since this guy's just been sitting here chilling, I'll show you what I did. Show run include IP or actually I'm going to do section OSPF. You can't do this in Packet Tracer. This is how you thin out your running config. Yeah, I know it's taking a minute. I may have to pause the video and see what's going on because my processor is still like spiked. I'm going to close out the okay, there it goes. It doesn't show what I did. That's weird. Show IP protocols. As you can see, it is an autonomous system boundary router, or border router, boundary router. It doesn't show it. And you ask, why is it an autonomous system boundary router? Because of the fact that it's it connects to an outside network other than OSPF, autonomous system ASBR, and the router ID is 172.20.0.70 or 170, which is the IP address of this guy because he is the highest configured IP address at the time. So if you do a show IP OSPF interfaces, hang on one second, let me see what's going on my computer. One of the things you can do with GNS3 is I will show you the task manager. And my task manager is goofy right now. I don't know what's going on with it. But if you see, I have a lot going in the background, but there's like a lot of Chrome too. That maybe Chrome would help close. That may help out a little bit. Hang on just one second for me. One of the things you need to do, let me close this out here, is the idle PC. The router thinks that this PC, or the CPU and the RAM on the computers, what the computer would use, is actually it. So what you need to do is, if you right click on, I'll do it again here in a second, apply, okay, yes. Now, that should slow my computer down. Yeah, it brought my CPU way down. So, what you need to do is right click on here and quit where it says idle PC, because that takes the actual process that's being used for the router, and it's responding a lot quicker now. So this guy right here was showing point to point on that guy, but it's showing that serial.102 is the DR, and that's what you want to see because that's what I set the priority at. Now and then it's non-broadcast, so I'm gonna console into this guy and do show IP OSPF interface, and you'll see right here state is druther because it's a priority of 0. So when you're configuring, you may be able to do this under the interface command, but what I did under R1 is when I was configuring it is I said show run. Does it show it? Because that just kind of bugs me that it doesn't show that I put the priority in there. Oh, I'm not there yet. Yeah, that's just weird that it doesn't show that I put in there. Because when I said, because you have to configure with the neighbor statement. I know for a fact the Packet Tracer doesn't support this. So when you configure OSPF over a frame relay or an ATM or an MPLS environment, you have to go in there and say neighbor and then type the neighbor you want to connect to. Because you can turn OSPF on all the routers and it will, after a few minutes, the neighbors will time out because there's got to be a neighbor statement, because OSPF is kind of funny across frame relay and NBMA. So you have to type in neighbor. Actually, you know what I'll do is I'll go in here, config T. I'll type in router OSPF 1. Type in neighbor. See, a neighbor, and then you would type in, so like 1.1.1.1. There, actually what I'll do is I'll type in 192. 192.168.1.0. 0.0.0.0. Oh, that's network. Let's kill all that. Now you click. I see where it says priority, OSPF priority of non-broadcast neighbor. If you're going to be over a non-broadcast network, which is different than a point-to-multipoint or filtering over over a point-to-point, which basically means if you're going to turn this to a hub-and-spoke environment, because technically this is full mesh. The way I have it set up, it's full mesh because this guy has routes to here. This guy also has routes to here. That's why there's two DELCs. It's router 3 to router 1 and router 3 to router 2. So I have the DELC set up like that, and click on this guy. As you can see, it's router 1, port 1 to port 2 and 3, port 2 to 1 and 3, and port 3 to 1 and 2. So it's got a full mesh configuration here. So with that being said, that's what you would have to do. So I put priority, and then you put 0, so that the spoke does not have anything to do with the election process, and that shows it right here. It's a druther, it's a DR other. It's not a DR or a BDR. It's just a router on the OSPF network. So that's one of the things that I wanted to show you so that you guys can understand that, because if you don't do it, then it's not going to work. Now, what I'm going to do here is I'm going to control U, and I'm going to say, I'm going to copy, I'm going to say no neighbor. I don't know if this is going to work, but 172.20.0.138 and then 39. Okay, so I just brought it down. So I'm just curious to see if this is going to work. If I go under show IP interface brief. See, I wanted you guys to see that. So I'm going to go under config. Oh, it did. Oh, I see what happened. 72.0.254. Okay. I don't exactly know what that was. Oh, that was the What was that? That's weird. Oh, you know what? I bet you it'll. Wow. I hope I didn't just say a whole bunch of stuff and I'm wrong now. It still sees it. Because it's 136/29. Let's go interface 00/0.201. Type in IP OSPF priority. What are my options? Oh, let's say I had to priority 0. Now I don't know if that's gonna do anything for me. Show IP protocols. Yeah, see, it's not routing for that one right now, as you can see. It's got, can I ping 172.20.0.138? I can. I can ping that one too. Well, isn't that just kind of a stinker? Because as far as I was to understand it, okay, you know what? I bet you. Let's do this and show IP. Let's see here. OSPF interfaces. Okay, it's still okay. This was different before. This is now the BDR because it's got a priority of 1. See how that changed? This guy's the BDR, and I bet you show IP OSPF interfaces. This guy has become. This guy's still the DR. Okay. What is R3 then? Because R3 has a higher IP address. Console. Show IP OSPF interfaces. Okay, he's the druther because he's still got a priority 0. It only worked on the one command then. So what we're going to do is we're going to go back to R1s. As you can see, the priority is 0, and we're going to go back to global config, and we're going to type in router control U router OSPF 1 neighbor 172.20.0.138 0.138 control E to the end and type in priority is 0, and that should reconverge. Oop. I may have to clear the table because now that it's. Let's see if that changed anything. Yeah, it's still acting as a BDR. So we're gonna clear IP OSPF star. Process. Not something you want to do in a production environment, but because yes. Now it just reconverged on everything. And show IP OSPF interfaces. He's reconverged. This guy is the druther now. That's funny. This guy is show IP OSPF interfaces. This guy is now the DR, and I bet you this guy will be the BDR. Oh, let's do that one more time. Oh, because he's still got a priority of 0. Okay, so he just reconverged on that guy. This guy is the This guy's the BDR because this guy's got it's working on this guy. So we're gonna go show IP OSPF neighbors, and we can see that 169 is full. 138 is the DR, which is this guy right here. So we're gonna go config T. We're gonna type in show our router OSPF 1. We type in neighbor 172.20.0.0.138. That's priority of 0. And we're going to go config T, type in interface 00/0 dot, was it 201? Yep, 201. IP OSPF priority is 0. And now I don't know if that's going to kick off a reconvergence or not. Yeah, it's not. Let's see here. We're going to clear the process. Yes. This is how you guarantee yourself some things here. So we're going to do show IPS interfaces. This guy is the... Oh, it's waiting. It hasn't converged yet. State is waiting, so it's not converging. Clear IP OSPF process. Yes. See, I break it and then I can't fix it. Gotta love that. So I'm gonna ping 172.20.0.138. I can still ping it, but I can't get if you want a lot of information on OSPF, that is how you do it. Show IP protocols. Oh, I see what I did. I advertised it for the entire range. Show IP route. Does it see the route? Well, it sees a route, so ping 172.20.0.138, 139. Show IP OSPF neighbors. X start. Oh, see, it's having an issue with trying to. Oh, there it goes. That's my fault. Sometimes it's like BGP, and I said this before in another video. Sometimes it just is slow. So we're gonna do show IP OSPF interfaces. OSPF, not FP. FP interfaces. And this guy again should be the DR, and he is. And this guy should be. This guy should be the druther because of the priority. So I jumped too fast. That's my fault. I'm not 100% at the CCNP level yet, so I do jump the gun a little every now and again. But let's see here, interfaces, and this guy is the druther because it's a priority of 0. That's how you guarantee yourself what it's going to be. So I wanted to kind of show you how you break it, and then you have to figure out what the problem is. I already knew what the problem was going to be, but I wanted to go back and make sure that you guys got it and understood it, and because that's going to be something I guess a lot of people are going to get hung up on. Now, one thing you could do is, like I said, go underneath the interface that you're going to connect OSPF on, and then put the priority 0 in there, and that probably will work. And as long as you can ping it through frame relay, you should have a connection to it, and go that way. So I didn't do any changes to anything here, and I'm going to get rid of this. You know what I might do is I think I'm going to add another router in here. And what I'll do is I'll bring out an Ethernet switch, and then I'll connect this guy to this guy, and that'll be another router. And I'll put once it's all set up, I'll put OSPF area 1 here, so you'll have multi-area. And actually, let me put in here OSPF area 0, and I'll put it over here, OSPF area 1. So now, the next time we go through this and finish things up, is actually I want to finish up the series this weekend, because I have my exam on Tuesday. So I want to be completely done with it, so that I know I've got everything pinned down, and then you guys can go ahead and see how that type of stuff works. And my goal is to, once I have everything situated, is so that I can run NAT to this out to here. So it'll be natting and ACLs to prevent certain subnets to get out, which is good for this, because then I can configure a whole bunch of subnets on this guy and go from there. And then if I wanted to, I could like attach a router to here. I'd make that like a backbone router, so the backbone router connects to this guy to the edge. So what'll end up happening is I can connect another router. Well, I can actually connect these two routers together, because they're the same subnet, and configure like HSRP, or like first hop redundancy, which basically means if this there's two connections, one here and then one here, then, or actually I'll just do it like this, I'll cover them up, so it'll look like that. So if I was to sever the connection here, users on this subnet over here would still be able to get off, even though that this is, another switch in this regard. So that's something I'll probably show you as well, because that's something I think that it's more of a CCNP switch topic, but I think you guys definitely should know how to do that type of stuff. So I think I'll add another router out here just for kicks, and this will be a backbone. I know my topology is starting to grow, but the point of this is to show you guys how to get this stuff done. And we'll put in backbone 1, and we'll put in we'll go with that, and then I'll attach a whole bunch of routes here, and then I'll advertise those into OSPF, and we'll go from there, because then this will just be a stub router, and I'll configure it as a stub, and this guy will be this will be a type 3 LSA, which is a network LSA. This will be just an edge router, and go from there. So I know this video is a little long, but I wanted to cover some things so you guys can understand it. So I hope this has been informative for you, and I would like to thank you for viewing.